This AgVision program is made possible through the generous support of Syngenta Seeds NK brand. The results you need, the freedom to choose. And by Farms.com. Ag news, market prices, ag careers, and farm real estate. You'll find it all at Farms.com.
Our top manager team has received many questions concerning biofuels from Canadian farmers, so we've invited Jake DeBruyn, who is an engineer in the new technology integration of the Ontario Ministry of Agriculture, Food and Rural Affairs. Jake has experience in a wide range of bioenergy related subjects, and so he's here today to share some of that insight with our AgVision viewers. Now, Jake, one of the reasons that we have you here, an Ontario-based bioenergy specialist speaking to farm managers across Canada, is that you're involved in what many consider to be a leading edge program that will likely set at least some of the benchmarks for energy programs across the country. Of course, I'm talking about the Standard Offer program. Can you explain why this is a leading edge initiative and what its pros and cons are?
Yeah, I guess in terms of when we look across the country at electricity supply, it's here in Ontario where we've become aware that we have to start considering other electricity options. The blackout in 2003, of course, raised awareness about our reliance on certain types of energy systems. And so that's really pushed the province to consider what are the alternatives. And when we look around to other jurisdictions around the world, it's clear that renewable energy is definitely an opportunity. So the Standard Offer program was introduced to capture some of those renewable energy opportunities. And so some of the obvious areas that we're looking at are wind, solar, and biogas as good opportunities for electricity production.
And what would you consider some of the pros and cons then of that program?
Well, the big opportunity is that we're providing a slightly higher price for power from renewable sources. So when we look at our existing electricity infrastructure, we've accounted for some of the costs over the long term that we've incurred for past choices in terms of our electricity supply. When we look at new opportunities like renewable energy, there's some costs that society isn't quite paying for yet. So if we're going to build capacity for wind turbines and so on, we need to invest maybe a little bit more at the front end until that technology comes down in price. So the Standard Offer program basically offers a better price, a higher price, to account for the fact that this is new technology and we haven't invested a lot in the past in this type of technology. Of course, if you want to try to identify a risk in that, I guess we're investing in innovation. Now, the opportunity here is that we're learning from other jurisdictions. So Europeans have done this broadly, and we're trying as much as possible to learn off the way that they've done it out there.
Now, we'll talk about ethanol in just a moment, but there is a great deal of interest in biogas systems. Can you describe for us how you see the opportunities in biogas? And actually, just by definition, are we primarily talking about using manure to create electricity, or is it more than that now?
Yeah, biogas is really exciting. It's basically energy from something that in general society is considering a waste. So biogas, as a real basic, is a big tank full of manure. The manure bubbles away anaerobically and produces this biogas, which is about 60% methane. And then we're going to burn that methane in a conventional internal combustion engine and produce electricity. And so this is great because we're capturing, we're using manure, we're capturing something that otherwise might have actually contributed to climate change issues, and we're turning it into something good. The next steps up from that are taking food-based inputs. So if I look at the food that you or I eat, that's just energy. And so for byproducts from the food management production system or byproducts from grocery stores and so on, that material has energy. And so if we put it in these digesters, we can harvest that energy. And then lastly, the next step is, what if we took agricultural crops, these are crops that, for instance, we fed to an animal, and we cut the animal out of the picture. So the energy that the animal might have harvested for their own growth, we're going to capture that benefit directly in the biogas system. And so that's energy crops. In particular, in Europe, they're looking at corn silage. So typically we feed a cow corn silage. Now we can feed that to an anaerobic digester and get, for instance, about 10 times the power out of corn silage that we would out of manure, which again was a waste product.
Right. You alluded to the fact that biogas type systems are not new, and they're not new here in Canada either. Though I do recall from a media perspective, roll back 20 years, a number of biodigesters that were set up, and in short order they went out of business. Has something significant changed to the technology of this that suddenly it's viable again?
Well, sure. If we look at the telephone that we used back 20 years ago, it was a black box with a dial on it. And of course, our technology has moved forward. The other thing is the price of electricity, because we probably haven't invested in our electricity infrastructure, prices have moved forward. Again, because some of the technology for biogas control systems and all that, the cost has come down. So a number of those factors are lining up to make biogas systems economical today. The sensors that are needed to ensure that these things are running well are cheaper. And so we have a better understanding. You always learn from mistakes. The first automobiles didn't work all that well, and we learned from those and moved on. And so biogas really, as an industry, its time has come. So for instance, if we look in Europe, there's probably over 4,000 operating farm-based or rural anaerobic digesters producing biogas. And so we don't have to reinvent the wheel here. We can look at that experience, we can take the best parts, and we can apply them here in Canada.
Let's move over to ethanol. We hear a lot that cellulosic ethanol is the future of that technology. What does that mean for the future of those who have invested in corn-based ethanol? Well,
to be clear, I think corn-based ethanol is sort of the first generation of ethanol. And that's because the production system producing ethanol from a starch like corn, or could be wheat, that's sort of an understood process. And so step one today is production of something we understand using inputs that we have readily accessible today. The next step, trying to harvest ethanol from a cellulose, so more of a woody type of plant material, that's seen as the next opportunity because of the abundance of these woody type materials and really the relative lack of value in that woody material. So if we could take, again, something that's considered a waste right now, and we could harvest energy from it, that's a great opportunity. So the corn-based ethanol approach, that's really taking off here in Ontario, for instance, across Canada, and really the United States especially. That's step one. And as we move into a cellulosic system, if the economics are good or better, I'd say that's where the future will lead us.
One of the first questions that we received with our top manager team here some time ago was with regard to on-farm biodiesel. Are you receiving much interest in that subject, and is that a viable idea?
Yeah, there's definitely a lot of interest. So when we consider biodiesel, the reason for interest is that the chemical reaction to produce biodiesel from plant-based oils is fairly straightforward. And so this could be sort of backyard basement chemistry that people think, yeah, I can do this myself, I can do this on farm. And certainly there are farm scale systems that are effective and produce a decent quality material. One of the questions on farm-based or sort of homebrew biodiesel will be, what's my input material? What's the quality of it? And so I might be able to access sort of a low-cost input. So if I have a waste oil product that I can get for a relatively affordable price, then that material I can produce a low-cost product. The challenge is a waste oil product. For instance, people talk about French fry oil that they're going to go collect from the local restaurant. The quality of that material may vary from batch to batch, and therefore the quality of material that you produce and you use in your tractor or your vehicles will also vary. The cost of doing testing of biodiesel is quite high, so somewhere between $500 and $1,000 a test to ensure it meets the appropriate ASTM standards. And so when we're doing it sort of on a small scale, we can't afford to test all the time, and so the result is we don't actually know the quality of the input material. When we look at using our own crops, so farmers will say, well, I'll buy a crusher, I'll bring a crusher in, I'll crush my own canola or soybeans or whatever the case might be. Part of the challenge there is, okay, again, the production of that oil on farm, the cost of doing that. That cost may make sense, but it doesn't seem that anybody's making that work right now. And so I think time will tell. I think we're right at the point right now of a number of people getting into that system, and as experience grows, that may be part of the future for farm-based energy production.